Today's lesson, section 3.3a, we'll be talking about dividing polynomials. So here, we'll start with division algorithm. Now, this works for when we're doing numbers, and it holds true for polynomials as well. So, if you have a polynomial p of x and d of x, and make sure that d of x is not 0, because we wouldn't be able to divide them, then there exist unique polynomials q of x and r of x, and they are either 0 or a degree less than the degree of d of x, such that the following thing holds true. So this is the algorithm, where you have p of x, so that's the main one, that's called the dividend, and that's going to equal the divisor, so what you divided this main polynomial by, times the quotient, so that's the answer of what you found after you divided using the divisor, plus the remainder. So sometimes, like if you did 7 divided by 3 in like grade school, 7 divided by 3 only goes into 7 twice, but you have a remainder of 1, so that's what they're talking about, the remainder. So in this case, if you're doing that, you would get 2 is your quotient, and that's your polynomial, 3 is your divisor, 7 is your dividend, and then remainder of 1 would be remainder. Okay, so that's kind of what they're talking about, and they want you to be able to write your answers in this kind of form. Okay, so example 1 wants us to be able to use long division to help us to do this. So just a reminder, I'm going to do this to the side. So long division for polynomials is very similar to long division for what you did in grade school. Now we usually don't do this anymore, but that's kind of what we're looking for. So 1,351 divided by 31, same things hold true. It's just the question kind of changes. So usually you would ask, how many times does 31 go into 13? It would be first, and then doesn't go into it at all, so you'd say 0. You move on to the next. Does 31 go into 135? Yes. How many times? So then you would have to calculate how many times. So 31 times 3 is 93, and then another 31 gets you 124, and it looks like that would be it. So you'd say 4, then you would subtract, and that would get you 11, bring down the 1, and then you would say, okay, it only goes into it 3 times just from what I showed. So 93 minus that, 111 minus 93, would get you So that would get you 8 and 1, so 18. So then you would say that 31 goes into 1,351 43 times, and there's a remainder of 18. Okay, so that would be your answer. Now, the only thing that's different, because everything else is the same, we want to be able to find what our divisor, or how many times our divisor goes into it, or to our bigger polynomial to find the quotient, and then we're going to have a remainder sometimes. Sometimes it may be 0, sometimes it will be another polynomial. So let's set this up. Like I was saying, the question will change here. So instead of asking how many times does x plus 2 go into 8x cubed minus 3x squared, that's kind of hard to answer. So what you want to do is, what times x gets me x, or 8x cubed. And so then that will help you match up what you want, because you want to be able to get these to be 0, right? So you can move on and find your remainder and quotient. So to get x to be 8x cubed, you would do 8x squared. And so then from there, now you would go do the same thing, because 4 you would take times 31 to get the 124 over here. We do the same thing. So 8x squared times this polynomial of x plus 2 gets us a new polynomial. So that gets you 8x cubed, and then 8x squared times 2 would be positive 16x squared. Now you want to be able to cancel them out, so you want to use subtraction like we did over there. So 8x cubed cancels out. Now negative 3x squared minus 16x squared, that gets you negative 19x squared. If you'd like to, you can distribute the negative through. That makes it easier for you. And now notice, I only have one term. I have two terms here, so I need to bring down the next one, just like you do in your regular long division for numbers. And then I want to do the same thing. So what times x gets me negative 19x squared? That would be negative 19x. So the first one in each line should be exactly the same as the one above it. The ones after it will usually be different, unless it becomes 0, and sometimes you get them to cancel out. So then negative 19x times 2 would be negative 38x. I want to subtract. Here would be a good idea to switch your signs. So then the x squareds cancel out. 2 plus 38x would be 40x. And then bring down your 1. So now what times x gets you 40x? It would be 40. So then multiply those, get you 40x. 40 times 2 gets you 80. Subtract. So the 40s cancel out. Or you could say negative 1 plus negative 80 gets you negative 81. So here, my answer would be 8x cubed minus 3x squared plus 2x minus 1 is equal to your divisor, so x plus 2, times your quotient, 8x minus 8x squared minus 19x plus 40 plus negative 81. And so then that would be your answer. Okay? If they want this answer, they'll ask it for you to put it in division algorithm form, and that's what that's supposed to look like. Okay? Letter B is looking for the same thing, a little shorter. So x minus 4, 6x squared minus 26x plus 12. So then what times x gets you 6x squared? It would be 6x. So that gets you 6x squared. 6x times negative 4 is negative 24. Subtract. Distribute through. So negative 26 plus 24 gets us negative 2x. Bring down the 12. Then what times x gets you negative 2x? That would be negative 2. So negative 2x. Negative 2 times negative 4 is positive 8. Subtract. Distribute. Those cancel out. 12 plus negative 8 would be 4. So then here my answer would be 6x squared minus 26x plus 12 equals x minus 4 times 6x minus 2 plus 4. Now sometimes you may get like a binomial as a remainder. Just know that it doesn't matter. So then next, another way of dividing is using synthetic division. Now this only works if your divisor is in this form of x minus c. Now there can be a number in front of the x, so you could say ax minus c, but just know that it needs to be a binomial of this form. So example 2 wants us to use synthetic division to do that. So here this is just kind of a refresher from advanced algebra, or algebra 2. So remember that for this one to work, this is c right here. So it's going to be not, so right now you have x minus c, so you kind of have to set this equal to 0 and solve. So I'm going to put in 3, not negative 3. And so then when I do synthetic division, I'm going to put in all my coefficients. Now notice that there is one missing, okay? And we always do this top coefficient and then work our way down to the constant. Now because there's nothing for the x, I need to actually put something there, so I need to put a 0. Okay, so this is for 0x. Okay, and then from there, because if you didn't have that, then your values would be messed up. So it's dependent on having those fillers if you need to have the fillers. Some problems don't, like letter B doesn't need a filler. Okay, so now remember with synthetic division, you want to always add down and multiply across. So 2 has nothing to add down to, so it's like 0. So 2 plus 0 would be 0, or 2. And then now you take your constant, or your c value, and you multiply it to this value, and put it diagonally underneath the -7, or the next number. So 3 times 2 gets us 6. And then I add down, so that gets me -1. I multiply -1 times 3 to get -3. Then I add down, so it gets me -3. And then I multiply, so it gets me -9. And then I add down, it gets me -4. Okay, so here I do the same thing, except now my answer will be 2x cubed minus 7x squared plus 5 is equal to my divisor, which was x minus 3, and then my new quotient. Now I'm going to attach these. So because I divided a value of x out, that means that it's my my quotient is going to be less, 1 less than what it was previously. So it still has the 2, but it'll be 2x squared because I factored out an x value out of everything, and then -1x minus 3, and then my remainder of -4. Now with synthetic division, because you're using a factor of a binomial, your remainder will always be a coefficient of just a number, no variables. Okay? So then letter B, same thing. I'll put my 3 in there because it's the same. I get 5, -2, 1, -10. And do the same thing, so add down. So I get 5, multiply across gets me 15, add down gets me 13, multiply across gets me 39, add down gets me 40, multiply gets me 120, and then add down gets me 110. So our answer will be 5x cubed minus 2x to the second plus x minus 10 equals x minus 3 times 5, remember 1 less than what you were previously, so since it was cubed, this one would be 5x squared, plus 13x plus 40 plus 110. Okay. Now next thing would be remainder theorem. So here, if a polynomial p of x is divided by our binomial, so the one that we use for synthetic division, then the remainder is going to be the value of p of c. So what it's saying here is that when you divide it by a binomial, so really you're dividing it by like what x equals, so like a 0, then when you use synthetic division, the value or the remainder that you end with is actually the value that represents the y value for that c. So it's almost like taking the c, plugging it into your function, and getting out the y value at the end. So it's like another way of plugging a number in. So here I have the polynomial function of 8x to the 5th minus 2x to the 4th plus 10x cubed plus x squared minus 20x plus 10. And I want to be able to divide it by x plus 2 and see what the remainder is. So I want to find them. So then I get -2. And then use all my coefficients. It looks like I have each one from the 5th all the way down. Okay, so then I add down, multiply gets me -16, add down it gets me -18. Multiply gets me 36, add down gets me 46. 46 times -2 is -92, add down is -91, multiply gets me 182, and add down gets me 162, and multiply 162 times -2 would be -324, and then add down, so it's -314. So then that would mean that p of negative 2 would equal negative 314 for this. So it's just another way of evaluating for a given x using synthetic division. Now we can also use that same thought process as a different way. So if we use the factor theorem, it means that if c is a 0 of p, if and only if x minus c is a factor of p of x. So if you're given a factor, then that means the value c is actually 0, so then it ends up meaning that you're going to get equal to 0. So you're going to get a remainder of 0, so it actually goes into it evenly. So if I use the factor theorem to show that x minus 2 is a factor of p of x, which is equal to x cubed plus 2x squared minus 3x minus 10. So then here, I can still use synthetic division. So I get 1, 2, negative 3, negative 10. So add down gets me 1, multiply gets me 2, add down gets me 4, multiply gets me 8, add down gets me 5, multiply gets me 10, add down gets me 0. So because I got 0 here, that means yes, it's a factor. And that would be it for this section. Okay, have fun.